Hello everyone, welcome to Module 3 of this course, which is hands-on light annotation. We will be doing some hands-on annotation using some of the tools that we discussed earlier, but before that, I would like to cover some challenges and best practices that are going to help us through our annotation journey. Um, like any other field, there are many challenges that we face during annotation process as well. Some of them are occlusion, noise, complex scenes, or even sparse data. These can be handled using certain mechanisms which we will discuss in brief here. Now, speaking of noise, imagine taking a picture in a foggy environment. A blur will be induced in the image, and certain objects won't be clear in it, right? Similarly, LiDARs can also have noise in their output data due to certain external or internal factors. Um, some of the common factors can be environmental interference like fog, rain, or snow, while some other might be due to laser sensor limitation itself. While noise can also be introduced when combining data from um, multiple sensors, multiple laser sensors, uh, there can be slight misalignment as the point from different scans may not perfectly overlap with each other. It is thus imperative to identify the parts in the point cloud that appear noisy and then take remedial action to fix them. If denoising is not done, it will result in a dip in the accuracy of the model that relies on such noisy data. We can use denoising filters to remedy this in the annotation tool to address such problem and clean up the stray points before annotating the point cloud. The part B of this image is a denoised version of A, where we can see the stray points being removed. Now, let us understand what occlusions are. Consider you're walking into a room and there's this huge sofa in front of you, behind which is a small chair. You are unable to see the chair since it is not directly in the line of sight. The same problem when faced by a LiDAR is called occlusion. As shown in this image, we see the LiDAR sensor placed towards the left side of the scene. There are many trees in front of the LiDAR, but there's this huge tree B at the center of the park, behind which is a smaller bush C. Since B is obstructing most of the LiDAR beams, the object C in the environment stays hidden, even when it is there. Such a phenomenon is occlusion, where we see no parts or a part of certain objects. And this can cause serious challenges when we try to map an environment. In such cases, to handle this, we only annotate the visible whole object and leave a comment or use partial object flags for the object that is incomplete in the 3D view. We can even rotate the 3D view to adjust to the best angle for annotation. Maybe the object is visible from another angle. Next problem could be sparse data. Uh, it's also commonly faced. It refers to situations where the point cloud has low density, which means there are fewer LiDAR points collected in a given area or volume. We can see in this image the left one has more dense point cloud data than the right one. Sparse data will often result in less accurate borders, which will in turn affect the accuracy of the mapping as well. To tackle this, we must use multiple perspectives if available to estimate the object's boundaries more accurately, such as top view, side view, and left view, right view, and so on. We can also cross check annotation against camera or sensor fusion data, which often functions along with the LiDAR sensor to map an environment. Annotating any 3D data is a complex task, but sometimes the scene in the environment we are mapping is itself can be very complex. This will create more difficulties in the annotation process. For example, this particular image has a dense point cloud, and it is somewhat difficult to differentiate between different objects in the scene. To remedy this problem, or to make the process more efficient and not compromise on the accuracy. We must annotate one object at a time to avoid errors caused by overlapping or tightly packed objects. Grouping related annotation, example, vehicles in a traffic jam, can also help in easier management. So, this brings us to the end of this session. Next, we will start with the most important part of this course, the annotation lab, where we will perform some hands on Lidar annotation using some popular tools. See you on the other side.